Okay, is my slide is visible to all? Okay. Okay, so we will wait for some moment, then we will start. Okay, so I think we should start now. Welcome you all. Good evening. My name is Ram Kumar Desmukh. I am doing PhD at IIT Roorkee in the Department of Paper Technology. I'm here PMRF Research Fellow. Uh, this course, Novel Technologies for Food Processing and Shelf Life Extension. We are here to solve previous year assignments. So this is my week 2 explanation video. I hope you are getting. So for those who have attended as a new today, uh, I'll introduce myself a little bit. I have done my B. Uh, in a dairy technology from Chhattisgarh Kamdev Vishwavidyalaya, Durg, and after my BTech, I completed my MTech in Food Science and Technology from Sambalpur University in 2018. After 18, I was working as in a Niptam Tanjavur, Tamil Nadu. Then joined as a project assistant at IIT Roorkee Paper Technology Department. Then in January 2022, I've joined as a PhD research scholar. And this May 2022, I've applied for PMRF and got selected in the cycle line from little entry. So this is about me. So uh, are you getting my voice clearly? Okay. So we'll go to question first. Denaturation of protein results in. So options are loss of its biological activity, decreased reactivity of constituent groups, increase in solubility, resistant to enzymatic hydrolysis. So what is the result when protein denaturates? So your options A, B, C, D. So those who know they can type on the chat box. Okay. After getting some few answers, I'll explain what will be the answer. Okay, Sayameri saying John saying A. Sifali Tripathi is also saying A. The loss of its biological activity. Nandita Tripathi is also saying A. Good. Rahul Raj also A. Okay. If you are watching the videos from this uh, course, you will get all the explanation there. So they have given the assignments on the basis of their lectures. If you are registered for this session course, so you must are getting assignments for every week, so you need to solve those, and you have some deadline. I think 1 week, I think that deadline is there. After deadline, there will be no choice of selecting answers. So after 1 week, they will release the answer key. So you cannot process, you cannot answer those questions. Okay, so your marks will not be added. So if you have registered for this course, you need to go and solve those assignments before ending the deadline. Then only your evaluation will be happen. Okay, then you will get the your certificate, because these assignments can also will be added to your certificate. So if you want to get certificate, or if you want to learn more, so I think you should go and solve those questions. And now everything is available online. Okay, if you are not getting things, you can ask here also. And if you are not getting, you can search on online also. So there are so many ways. And NPTEL has doing giving us opportunity to explain those questions if you are not getting, but not the same question as this session. Okay, so we will explain previous year questions, so you can also do. But I as my experience, I can say if you are attending classes, so you will not need to you will not need particularly for any assistance. You can, if you are a food science student, you can go to different books to well understanding. Okay, so what is answer? Only four people have given the answer: loss of its biological activity. So its answer is A. Those who have given loss of its biological activity are correct. So denaturation causes the loss of biological activity, increase reactivity of consistent group, decrease in solubility and susceptibility to enzymatic hydrolysis. What happens when denaturation occur? When denaturation occur, this happens with different factors. Okay, there will be like change in pH, very high temperature, ionic strength, or very high solubility. So when the denaturation happen, what the coiled protein will be unfolded, like you are seeing in the on the skin. These has a normal. Okay, this is a normal protein, and if you are providing, if this has exposed to a high pH, temperature, or ionic strength, it will denature and the structure will be unfolded. So denaturation in biological process modifying the molecular structure of protein. It is a modification of the protein structure. This involves in the breaking of many weak linkage bonds like hydrogen bonds within the protein molecules that are responsible for the highly ordered structure of protein in its structure or native state. So denatured protein have a looser, more random structure, more or insoluble, and denaturation can be brought about in a various way: by heating, by treatment with the alkali, urea, detergent, and heating at high temperature, vigorous shaking. So now you got to what happens when the protein denaturates. Okay, so our second question is which of the following is the structural property of protein? Your options are emulsification, coagulation, cohesion, and gelation. So answer your in the chat box if you know which of the following is a structural property of protein. So Nandita is saying B, Saya Mary is saying C, Cephalic Tripathi is also saying uh, B. Today we have a very few people. Last week we have I think more than 40 to 50 peoples we have. Today, I think they are busy with their work or something. Okay, we are joining one by one. So, welcome all learners. So, please tell your answer. Okay, so answer is a cohesion. Okay, why? Because emulsification, coagulation, and gelation comes under surface enzymatic property and rheological property of protein, and cohesion, elasticity, and grittiness and chaviness are the structural property of protein. So there are different properties, different category of classification of properties. So these emulsification, coagulation, and gelation comes under rheological properties, and your cohesion, elasticity, grittiness, and chaviness comes under the structural property. You can tell by this name also, cohesion, grittiness, elasticity. So where this elasticity will come? When you have something with it's come under the structure, you have some rubber or some material, so whether it is elastic, whether it is cohesive or not, whether it is gritty, there will be grittiness or not, chaviness. So these all things will come in the structural property. And coagulation is a phenomena when your liquid gets very thick. Okay, emulsification, when we try to prepare some solution, so we try to make those in different solute or solution, solutes, solvents. So this is a emulsification, angulation. So this comes under the property of surface and rheological properties. Okay, so what is the answer? The answer will be uh, cohesion, which comes under the structural property of protein. So those who have answered C are correct for this question. Question 3: which of the following is not in the category of hydrophilic polymer? So question is, which of the following is not in the category of hydrophilic polymer? They are asking not in the category of polymer. So you have to read the question very carefully. Uh, Polydimethyl siloxane, polyvinyl alcohol, cellulose acetate, and polydiacetic co-glycolic acid. So you have to answer whether A, B, or C, or D. So you can answer on chat box. So Lokesh Kumar saying C. Sayameri saying C. A. Sorry. Sepalithik party also saying C. Okay. Gone. Someone has raised his hand. Okay. If you have any question, please you can ask. Anyone? Okay, so answer is a polydimethyl siloxane is not a hydrophilic polymer. Polyvinyl alcohol, cellulose acetate are hydrophilic polymers. Hydrophilic polymers are like polydimethyl siloxane. They attract or they allow the permission of water through their packaging matrix. So hydrophilic polymers allow or permits water penetration or permeation. So these kind of polymers called hydrophilic, with, where whereas the polydimethylsiloxane is a hydrophobic. They don't allow the water or your aqueous solution to permeate through the matrix. So answer is A, PDMS or polydimethyl siloxane. So next question is question 4. Which among the following membrane process rejects bacteria, viruses, and suspended food? So your options are microfiltration, ultrafiltration, nanofiltration. B, microfiltration, nanofiltration, reverse osmosis. Ultrafiltration, nanofiltration, reverse osmosis, and D, microfiltration, ultrafiltration, and reverse osmosis. So, which is the answer? Which will be the correct answer for membrane that rejects bacteria, virus, and suspended solids? Please answer your uh, choices in the comment box. Or okay, Namfuri saying C, Saya Mary also saying C. Okay, so we are also putting the I think you must you all getting the link from the public seat, okay? Because what we are taking classes in this live classes, they're also available in the YouTube, okay? So if you are not getting any classes, so you can ask the link also, because if you will go to the link, if some people have raised, like they have asked questions, uh, I had not allowed the public access. So if you are getting any uh, problem or facing the any issue with the access of those files, you can ask, because we have uploaded the PPT also there, and backup video is there. YouTube link is also there, so you can always ask whether you are getting or not. Okay, okay. Then Rahul Raj is also saying C. Ranu Priya is saying C. Nandita Tripathi is saying C. Okay, so answer is C. The ultrafiltration, nanofiltration, and reverse osmosis. Microfiltration do not allow the permission of virus, but ultrafiltration, nanofiltration, RO eliminates those. Okay, so answer is ultra, nano, and reverse osmosis. So you can see from this structure, microfiltration has a size of pore size of zero point 0.1 to 5 micron. Ultrafiltration has 20 nanometer to zero point 0.1 micron. Nanofiltration is less than 1 nanometer, and RO is zero point 0.1 to 1 nanometer. So when you go from micro to RO or nano, okay, the pore size will be lower. So if your material size is increasing or decreasing, so upon the pore size it will allow, like for microfiltration, suspended particles will be filtered. For ultrafiltration, selected macromolecules like your proteins, your carbohydrate will be filtered. Then your nanofiltration, multivalent salts, small solids will be filtered. And for RO there will be salts which will be filtered, but water will go through all the filtration. So what are those membrane? What are the filtration process? Filtration is a process of removing particulate matter from water by forcing the water through porous media. Like suppose you have something, suppose you made tea, okay? Every day you prepare tea, you put there different kind of things, like you put chai patti, okay? You put adrak also. So they have a different size, Okay, so what we do at last, we filter through that oh, chalni, we call it chalni, like in Hindi. So we filter those particles are, those particles are bigger than the filter. Okay, so they have, we can suspend those particle, we can filter out, and we can throw them out. But those particles which are smaller, okay, like if you have sugar, they have dissolved, okay, so it will go through the filter. Okay, water is, so water, you have seen that water can go through the all the filtration, membrane filtration. So this is technique, this is the pore size, like micro, ultra, nano, ro. So upon your application, which type of suspended particles you want to remove, or you want to filter, you can apply those membrane. This porous media can be neutral in case of sand, gravel, clay, can be membrane wall made of various materials. Sometimes you have seen, if you have seen these these membranes, what are those membranes? What are they made up of? In previous time, what people used to do, or now also you can see in a village, people from the tap also, they use some filter, whether it is a cloth, whether it is a uh, mm, like customized filter is also there. So they want to remove those suspended or bigger particle, what are particles are coming, which is not desirable in the drinking water, or some whatever the use you are doing water. Okay, so these are the filtration. But in if you will talk in the science, or in the uh, scientific area, so these are membranes, micro, ultra, nano, ro are the especially designed for different range of particles. So ultrafiltration has a pore size of 0.01 micron. A microfiltration filter has a pore size around zero point 0.1 micron. When water undergoes microfiltration, many microorganisms are removed, but virus remains the water. Okay, so you can see that virus is a virus. The size of virus is lesser, so it will remain in the water. So ultrafiltration would remove these larger particle, but they cannot remove the virus. Neither microfiltration or ultrafiltration can remove or dissolve. The nanofiltration pore size is around 0.0 or 1 nanometer, so they can remove those viruses and salts, range of salts. So you can get these from the PPT when I will upload it to the. Okay, so what these process do? So as I told you, depend upon your application, you apply those membranes, ultrafiltration remove bacteria, protozoa, some viruses, nanofiltration remove microbes, as well as natural organic matter, some natural minerals, especially divalent. And nanofiltration does not remove the dissolved compound, which is dissolved. Like I am saying, if you have dissolved something in water, okay, if it is completely dissolved, you cannot remove it. Okay, so these are the application which we use in a different industry, like wine, or purifying water industries. So these are very high technique which we do not use in the daily life, because we don't need, I think we don't need in the daily life. But ROU we use, if if your area getting water getting is not good quality, okay, so we use ro. So these things work there. Okay, so now the fifth question is, fruit juice having 10% soluble solid is concentrated by reverse osmosis up to 30% soluble solid. If the feed is flowing at rate of 20 kg per minute, calculate the membrane performance in terms of the conversion percentage. So this is a numerical type question. So you uh, solve. I'll give you some time to solve it. Then I will explain how you can solve this. Okay, so you solve. This is saying like fruit juice. Uh, this is the last question. What we have seen the filtration of membrane. It is based on that, but they have given some numbers. So you need to find out what is the performance or what is the filtration rate or conversion percentage. So you can if you have attended the class like it is a fourth third or fourth week class, I think, if I'm right. Okay, so if you have not attended, you can go and attend the class, so you will get better understanding about this. So okay, so let me explain. So what is a mass rate? Mass rate of feed is 20 kg per minute. Soluble solid content is 10%. 10%. Okay, and soluble solid content of product is solid content is 0.3% or 30%. Okay, so applying total mass is like total mass flow rate equal to mass flow rate of product and rate. So solid will be the 20 into zero point 0.1 equal to the mass rate of product into total solid content of product. So MP will be the 6.67 kg. The conversion rate is the conversion rate equal to the total mass balance upon the mass flow rate into 100. So what will happen? It is just a 6.6. You can you are what you are getting the percentage of 20 kg per minute. So 6.67 kg per minute will be the 33% 35% of 20 kg. So this is the answer. Okay, okay, sorry, it was mute. uh, that's why that was I saying now. So mass flow rate of feed is 20 kg per minute. Soluble solid content of feed is 10%. Soluble solid content of product is 30%. So total mass balance will be uh, mass rate of the product and mass balance of product. That will be 20 equal to 20. So what will happen? Solid is mf into x is equal to mp equal to xp. So 20 into zero point 0.1 then will be mass total mass rate will be, when you will solve, this will come 6.67, and total mass rate is 20 kg per minute. So you just need to find out the percentage. So what we will do, mass rate total the mass rate upon the total mass rate, okay, into 100. So 6.67 upon 20 into 100. So the answer comes to the 33%, 33.35%. So this 6.67 is the answer, but you have total mass rate is a 20 kg. So how much percentage of this 20 kg? So you just need to uh, calculate the percentage. What percentage the mass rate is, conversion rate is. So you got it. So answer is A, 33 to 33.5. Okay. Any question on this? Okay, you just need to remember some basic formula, so you will get it. Then you can calculate, because the questions is a very like basic question, so you can find out with basic calculation. The question 6, which of the following material is suitable for high pressure treatment? So you need to tell for high pressure treatment which of the packaging material is uh, suitable. So first is a EVOH, PVOH, copolymer films, semi-rigid tray, metal cans or paper bags. So for high pressure processing, if you are applying some high pressure, so which kind of packaging material will be suitable? So you can answer into the chat box. Okay, which are the packaging materials suitable for high pressure treatment? Metal cans, semi-rigid tray. Saya Mary John is saying, Rahul Raj is saying B. Ranu is saying B. Saya Mary is saying A. And Nampure is saying C and D. Okay, you can also say two or three. Okay, two, not three, because this is a this will be one only will be the right. But if you have confusion between two, B or C or A or B, so you can say, because at least you are going nearby that uh, your choice. Okay, so answer will be D. Airtight flexible packages that can withstand a change in the volume corresponding to the compressibility of the product are needed. The packaging material must be able to accommodate up to 15% reduction in the volume. Plastic films like EBOH and PVOH and sometimes semi-rigid trays are generally used, but metal cans and glass containers are not preferred. Okay, so answer is D. Plastic films that can be used also, but when we use paper kind of material, so that allow to sometimes what we see in paper packaging, when we put some material into the it, you can increase, you can decrease the volume also. Okay, so the reduction in volume needs in a high pressure process treatment, like you are using some packaging films like EVOH, POH. Sometimes rigid tray are also generally used, but mostly in the case paper bags are preferred. But metal, because metal cans cannot you cannot because metal cans are rigid. Okay, it has a perfect size. If you have made it 1 kg or half kg, you cannot if you will uh, if you will put high pressure, it will not allow to shrinkage your to affect the high pressure processing. So your whatever the process, whatever the force you are applying on the your product, it will not be applied to the your product. So your force is a waste. So you cannot allow, you cannot use those metal cans or glass container, because they cannot reduce the volume if pressure is applied. What happens when we push some flexible packaging? Okay, have you seen that any package, okay, plastic package? So when we push together, okay, with hand, they reduce the volume, so there will be some effect in the product also. So when we apply high pressure for some food product or some fruits like meat, okay, meat product, so we need to assure that if you are applying the pressure, it should go, it should affect the product. It should kill the microorganisms, whatever our objective is. So these kind of materials, if you are applying, so it will be useful. But if you are applying metal cans or glass, those are waste, because the pressure you are applying, it will be not going to or reaching to your product. Maybe sometimes if it is higher than their potential, it will break, and your all product, all lot will be the contaminated. So we don't use the rigid or semi-rigid trays. But if you have told A or D, those will be like right answer, because sometimes we also use EBO, OAPU, or like LDPE. polymers, but mostly paper bags are preferred because flexible package that can withstand to change in the volume corresponding to the compressibility. The major objective is to, if your packaging material is compressible, okay, when we are applying pressure, so your application will be successful. So whether your packaging material is there is ability to compress or reduction in volume, so you can apply in the high pressure processing. Okay. Question 7. Which among the following is a characteristics of supercritical fluid? So transport option is a transport properties as that of liquid like viscosity, gas like diffusivity, and positive surface tension. So which will be the answer? Please write in the comment box. Okay, okay. Someone is said the right thing. I think paper bags. Rahul Raj, you are right, because paper bags this is very fragile. Okay, so you cannot use those paper bags. So metal and paper bags you cannot use. Okay, sorry for the answer will be A or B. Okay, but mostly A is used. So those who have answered A, those are correct, and those who have answered B also correct. Okay, so this will be the two will be the answer. Okay, that A and B, because paper bag, if you have seen that paper bag is very fragile. If you will apply some force, it will break, it will rupture. So we cannot. Okay, Rahul Raj, good observation. So you need to pay attention. Okay, what someone is saying, then only you will get the right thing. Otherwise, you will just go with the bhed chal, I think. So you need to pay attention. Okay, so what will be the next answer? Which among the following is a characteristic of supercritical fluid? Transport property as that of liquid like viscosity, gas like diffusivity, positive surface tension. Please answer. They're saying C. Ranu Priya is also saying C. Sudeep, Saya Mary. Okay, so anyone who has answered the. Okay, Sudeep Baghel, Sifali Tripathi saying B and C, Sudeep Baghel saying C and A. Okay, so answer is a gas-like diffusivity. What is supercritical fluid? It is a fluid that is highly compressed and combined. It has a combined properties of gases and liquid. Okay, so if it has a high compressed or highly processed, highly pressurized, so it has both liquid and gases. So supercritical fluid have high solvent power due to their liquid like densities, and they have excellent transport properties owing to gas like viscosity. So they both have the liquid like and gas like property, because it is highly pressurized liquid, and diffusivity together with a zero surface tension. The transport property of supercritical properties are intermediate between the liquid and gas. So the properties of supercritical is gas like diffusivity. Okay, because they have a very zero surface tension, and they have excellent solvent properties and gas-like diffusivity. But if we are using in the different kind of solvent extraction, so they will go into your core, whatever the material you're using, it will go into the core of your material, and it will attract the extract the your components from the material. So the diffusivity of this supercritical fluid is like gas, because it has a both liquid and gas property. So answer will be C. Question 8. Which of the following factors does or do not influence power absorbed by the food in microwave heating? So if all of you have seen the microwave, and how does it heat, or how does it work, so what are the factors that do not influence the power absorbed by the food in microwave? That is frequency, electrical field strength, both frequency and field strength, and temperature. So which are these four options? Okay, which do not affect or influence the power absorbed in the food in microwave heating? You answer in the comment box. So Sayamir is saying C. Rahul Raj also saying C. Okay, good. Okay, answer. Sudeep is saying C. Sayamir is saying C. D. Okay, okay. You have answered two times. Okay, good. Okay, so anyone? So answer D is right, because temperature does not influence the power absorbed by the food in microwave. The power absorbed by food depends upon the four factors. Okay, frequency, electrical field strength, loss tangent, and dielectric constant, but not on temperature. So answer will be D. So we'll okay. So how does your microwave work? So microwave heating is a multi-physics phenomena that involves electromagnetic waves and heat transfer. Any material that is exposed to the electromagnetic radiation will be heated. Okay, so when we put our food or food material into the that microwave, that will rapidly heat. Okay, because it generates the electromagnetic field. Okay, so any electric field applied to the conductive material will cause current to flow. Time varying electric field will cause dipolar molecules such as water to oscillate back and forth. So in a lesser time you can heat the all food, all mass of food. So this is the process, or this is a your mechanism when we heat food in the microwave, because our food contains water. Okay, so water act as a dipolar molecule. So when we heat, the electromagnetic field generates, and it the oscillate like oscillatingly, like it is a what it you can say vibration occurs. So one molecules heats and transfer to the other molecules. So it collectively it all hits the all mass of food. Okay, so temperature doesn't play any role, or any does not influence the power absorbed by the food. So answer is a temperature. Identify the incorrect statement with the respect to microwave heating of food. So we have just discussed about the microwave heating of food. So you can find out which one of these Which one of this statement is incorrect? Shorter the frequency, higher the permeation. Microwave absorption is directly proportional to the depth. Penetration depth of microwave is inversely proportional to the loss tangent. Thermal runaway results in a non-uniform heating. So, what is the answer? Please uh, say in the comment box. Okay. So, Saya Mary saying B, Nandita Tripathi saying D. Okay. Okay. So, answer is B. Microwave absorption is directly proportional to the depth. Microwave absorption decreases exponentially with the depth. The penetration depth is inversely proportional to frequency. The frequency will increase, the depth will also increase, as well as tangent. So answer is a B. The microwave absorption is directly proportional to the depth. Is a incorrect statement. The ionic conductance results in the hot area receiving more energy than the cooler area. Okay, when we heat something, so our heated particle will transfer the heat to the cold part. So it will the the cold area will receive more energy. This phenomena is called thermal runaway that cause uniform heating. Okay, when we heat something, if you have seen in normal also, when we heat something, that heating area, whatever the cold area will be, so the part which we are heating directly, okay, will dissipate the energy through the cold area. So this is called thermal runaway, and that is after some time the full area whatever material will be, it will be heated uniformly. So the uniform distribution happens in this way, that is called thermal runaway. Okay, so this is a microwave heating principle. Like you have this chamber where you put your food. Okay, there will be magnetron which will generate the magnetic field and conduct magnetic electromagnetic field or radiation, which will rapidly heat your food. So your food product will contain water, will rapidly oscillate. Okay, so then transfer to the cold molecules, and all of a sudden, very in quick time, the all food part or all the food part, okay, will be heated. Okay, so this question 10th is calculate the dissipation constant for material which has a dielectric loss factor 15 and dielectric constant 15 plus 65. So if you know the formula, you can calculate quickly. Okay, so we should not waste time on this. So the dissipation constant or loss tangent, or the formula is the dielectric loss factor upon dielectric loss constant. So there is a nothing, you just need to know what is the formula and just put, that is a dielectric loss factor is a 15 and dielectric loss constant is a 65. So calculation you will get 0.2231. So your option will be B. Okay, so you just need to know what is the formula. And question 11 is which among of the following organism is the most sensitive to ionizing radiation? Bacillus cereus, Deinococcus radiodurans, Toxoplasma gondii, or Dipterion by diverse. dye virus. So what is your answer? You can comment in the chat box. So I am already saying C. So most sensitive microorganisms to the ionizing radiation. So ionizing radiation is that can change or alter the biological structure, biological things. Okay, so which of these microorganisms they have most sensitive or they can be affected by the ionizing radiation? You have to tell here. Ranu is saying A, Bacillus. Mary is saying C, Toxoplasma. Okay, so answer is C, Toxoplasma. So uh, Mary is right. The smaller and the simpler the organism, the higher the dose of radiation that is needed to destroy. The diphtherium by divirus is a virus, especially and species and virus are very resistant to radiation, which unlikely to be affected by the dose level and used in the commercial processing. Okay, spore forming species like Bacillus cereus and those that are able to repair the DNA rapidly, for example, Deinococcus radiodurans are more resistant than uh, vegetative cells and non-spore forming bacteria. Insects that is requiring low doses. Toxoplasma is inactivated at a dose of 0.025 kg. Means that toxoplasma is very what uh, very lower amount of radiation we will need. So what is the answer? Toxoplasma gondii is the answer. Other are some are having the resistance property, some are lead some are like vegetative cells, so they need more amount of or more doses of radiation, so they are not sensitive to the ionizing radiation, but the Toxoplasma gondii is the most sensitive mm, microorganisms which affected by the level of very smaller level of radiation. Okay, so what are ionizing radiation that produces the that can be produced as either natural or artificial source. It has a more energy than non-ionizing radiation, enough to cause chemical changes by breaking chemical bondage bonds. This can also damage to the living tissue. So ionizing radiation that can change the chemical changes or that can alter the biological or chemical structure of the living tissue. Uh, Generally, gamma and X-ray radiation, which are at the upper end of electromagnetic spectrum, have very high frequency in the range of 100 billion hertz. Very shorter wavelength or mm, radiation that use radiation in the range has a high energy, and it has a high enough energy to strip the electron from atoms in a very high energy radiation that will break the nucleus of the atom and can lead to chemical changes by breaking the chemical bonds. So uh, these kind of radiation process apply for the safety of food product for very shorter time, like micro or maybe the nanoseconds, with a higher rate of high frequency. So our food product can be stable for longer time. Okay, so I think we should stop here uh, because this is, I think, we have done it 55 minutes. So one question is there. So what is the penetration depth of microwave emitted at a frequency of 2450 megahertz in a row and raw potato, which has a dielectric constant and tangent. The speed of wave may be taken as a 3. So I will tell you that answer will be in the next week. So this will be the homework for all of you. So do your homework and come in the next class. So we'll have discussion in the next class. So uh, till now, I think we can stop class now. Thank you for all your attention and classes. Uh, Thank you. If you have any question, you can ask, or you can. Thank you all for attending the class and listening very carefully. If you have any question, you can ask me. Okay, and if you have any issue with accessing the files, you can ask that also. Okay. So thank you for attending the class. We'll see you in the next class. Okay. Seya Singh has read. Okay. Ask your question. What is in your mind, Seya? Good evening. Okay. Okay. Okay, browning means they are happening. There will be oxidation process is occurring. Okay, so oxidation process. If your product is oxidized, okay, it is not advisable to use it. So, what is your application or what you want to do with that onion? That is a very uh, uh, okay. What is your application or what you want to do with that product when you done with the sun drying? You are going for some research or you are doing something with for consumption. So yeah. Okay, research. If you are doing research, okay, so you can find it by yourself because I have not never heard like sun drying for onions. Okay, because if it is getting brown, so there is a color changes. Okay, so if it is color changing, so I think it is not advisable to use it further. Okay, so what did you do before and after? What did you do that is like changed the like before you are doing just cutting and what you did, and now it is not. Okay, so you have not applied anything externally to save your color from the onion. Okay, so now you're getting what you did wrong or something. Okay, so what you can do, you can smell your product. Okay, if you are you are making something like if the smell is coming like rancid na, you know the rancid flavor. Okay, if it is coming from the product, so I think it is not advisable. And you can read for more for this if any previous research has gone through the sun drying of this onion. Okay, please let me know in the class next class what you have, and also I will also go through some papers and let you know if there is any effect on the sun drying on the quality of onion. Okay. 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 Okay, anyone have any question? So, if you have not, then we can close the session. Thank you very much. Now you can leave the meeting. Thank you. Thank you very much.